Hello students. In this module, we have to talk about K nearest neighbor, KNN. Let's have a look about the learning objective. So first of all, we have to take in some basic idea about what is the meaning behind the K nearest neighbor, and then we have to see one of the example based upon KNN classification. So let's get to know about K nearest neighbor. Basically, the K nearest neighbor it is a part of the classification part. Okay, so in a classification, we already learn about the logistic regression. So in a next way, there is k nearest neighbor is there. Also in a classification part, the decision tree, support vector machine, and many more techniques are there. But here we are just only focused based upon a k nearest neighbor. K nearest neighbor algorithm is used to assign a data points to cluster based upon a similarity measurement. It uses a supervised method for a classification. K-nearest neighbor is a simple algorithm that stores all available cases and classify new cases based on a similarity measures, for example, distance function. KNN has been used in statistical estimation and pattern recognition already in the beginning of 1970s as a non-parametric technique. In statistics, the k-nearest neighbor algorithm is a non-parametric method proposed by Thomas Cover used for classification and regression. In both cases, the input consists of the k closest training example in the feature space as well as. So let's check it out what type of steps we have to taken during the KNN algorithm. So first is the choose the number of k and distance metric. So at the same time we have to find out how many k was necessary. K is equals to 5, 3, 6, 4, whatever the number we have to select. So that is the k. Second thing, there is a find k nearest neighbor of the sample that you want to classify. And third one, that is the assign the class label by majority what. So similarly, we are seeing some example or we are seeing some practical example based upon the k nearest neighbor. So we are getting some better idea about these steps. So let's get to know something more about for the KNN classification or the KNN techniques. A new input point is classified in the category such that it has a greatest number of neighbors from that category. So one of the simplest decision procedure that can be used for classification is the nearest neighbor rule is there, and it classifies a sample based on the category of its nearest neighbor. So the nearest neighbor based classifier use some or all the patterns available in the training set to classify a test pattern. For example, classify a pattern as a high risk or a low risk, as well as mark email as a spam or not spam. So let's understand KNN example from the real world life. So here I have one problem statement. So first of all, we have to read this problem statement, and based upon this problem statement, we have to try it out how we can explore the KNN classification method technique to over here to get some solution. Suppose we have a height, weight, and t-shirt size of some customer, and we need to predict the t-shirt size of a new customer given only height and weight information what we have already in this table. So the data including height, weight, and t-shirt size information already provided over here in this diagram or a table. So for that we have to go with the step number one. So first of all we are going to solve about the step number one. In a step number one, calculate the similarity based on a distance function. So there are many distance function, but we have to refer the Euclidean distance. So but the Euclidean is the most commonly used measured distances there. It is mainly used when data is continuous. Manhattan distance is also very common for a continuous variables. Whenever you are working like KNN K nearest neighbor technique with the continuous variable or the regression type of problem, you have to go with the Manhattan distance. But particular KNN technique is much popular with the classification part. So that's why whenever we are going with the classification, we are using the Euclidean distance. The idea to use distance measure is to find the distance or similarities between new samples and the training case, and then finds the k closest customer to new customer in terms of the heights and weights. New customer named Monica has height 161 centimeter and weight is 61 kg. So based upon Monica parameter, we have to do some subtraction between this parameter, or we have to take in some things related to the table parameter. So Euclidean distance between first observation and the new observation. First observation, it is the 158, 58 and m. and the Monica observation that was 161 and 61 kg. So 161 minus 158, because new observation it's a 161 and the first observation that was 158, so we have to provide to power of that one, plus we have to take in 61 minus 58. 61 it's coming from the first observation, sorry, the new observation, and 58 it will come from the first observation. So that's how we are finding out this Euclidean distance over here. So similarly we calculate the things, and we have to explore some more thing, like we will to calculate the distance of all training cases with the new case, and they calculate the rank in terms of the particularly distance, and the smallest distance value will be ranked as 1 and considered as the nearest neighbor. Now let's talk about the step number 2. So what type of thing we have to done in a step number 2? Step number 2 is depends upon the find k nearest neighbor. In a step number 2 we have to work based upon a nearest neighbor. So for example, here I have to take an k is equals to 5. So then the algorithm searches for the five customer closest to Monica. Like for example, we have to find out those five customers parameter specification. Those are very related to the Monica parameter. Like Monica has size of 161 centimeter and 61 kgs is there. So we have to find out that more five customers that they have specification related to Monica. So according to that one, we are getting an idea which type of t-shirt size will Monica will have. So, for example, most similar to Monica in terms of the attributes, and see what categories those five customer wearing. If four of them had medium t-shirt size and one had large t-shirt size, then your best guess for Monica is medium t-shirt size. So see the calculation in particular snapshot. So here I can provide everything like according to the snapshot. Like Monica are having 161. So here from over here we are taken these five samples at the same time. The height is 160, 160, 163, and 163. It's around like 160 to 163 is there, and Monica are having 61. Again, similarly in a weight, Monica having 61 kg of weight, and here we have to take on 60, 60, 61, 61, and 61. So samples are very nearer to that one. And if you can see this diagram, so in this diagram, yellow point will represent the Monica, okay, and also the blue point are represent this particular type of the medium t-shirt size, and orange will represent the orange square will represent the large sizes there. So here out of five, the 4 point will represent like Monica will fitted with the blue size, so Monica will go with the medium size. So in the above graph, binary dependent variable is displayed in the blue and the orange color. So medium t-shirt size is in blue color, and the large t-shirt size is, it comes in an orange color. So new customer information is exhibits in a yellow color for blue highlighted data points, and orange highlighted data points are close to yellow circle. So the prediction for the new case is blue highlighted data point, which is medium t-shirt size. So that's how we are able to explore the k nearest neighbor classification over here. Okay, so that's how this of the KNN method is completed over here, because the KNN method is not very longest or very toughest. It is very smallest and very easiest technique is there in classification part. So KNN should be ended over here. In this practical session, we have to implement a k nearest neighbor with the same data set that we can use already use for the logistic regression. So we are getting an idea how the output should differ from the logistic regression and the k nearest neighbor, because at the same time we are getting the true positive around 63. So here we have to find out what type of number of true positive, it means on what type of the condition and on what level of the condition we are getting the same in predicted output and the actual output. So at the same time we are getting idea about the accuracy. So let's start it with the first step, that is import the libraries. So first we have to import the numpy as np. Second we have to import pandas as PD. Third library is based upon a import matplotlib dot pyplot as PLT. Also, we have to use this backend line, that is the matplotlib inline. So after applying this one, next step that is the import the data set. But still we are getting an error. Matplotlib spelling was wrong over here. Okay, so now it's time to import the data set. Again, I want to use the same data set that I already used for the logistic regression. That's why you already aware about how to import the data set with the pandas dot read dot underscore CSV. Particularly, we have to use the social network advertisement data set. That's why we have to take an
social network advertisement data set ADV dot CSV. So that's how we have to do the things. And now based upon that same input parameter I want to use over here, that I can use for the logistic regression. See here I want to just only find out to do the difference between the logistic regression and the KNN neighbor in terms of the output or the accuracy or the confusion matrix, whatever things you can understand. That's why same input I should taken for the k nearest neighbor what I already taken for the logistic regression. So that's why again here we have to take a data set dot I location, and particular with that I location we have to take a number of rows, and with that also we have to take in 2 and 3, that is the position of the columns. At the end we have to provide the values over here. Then we have to take in y is equals to data set dot I location, and particular with that I location we have to take a semicolon, and then again we have to take in a square bracket. But if you just only want to select single parameter as a y parameter, no need to provide any type of the square bracket over here. And after applying this one we have to take in the values again over here, so we already getting an idea. I think again we are not finding out the social network advertisement data. I think the spelling was wrong. ADS. ADS. There is the ADS. Yes. Now it's correct. So we are getting X and Y is there. If you want to do some basics analysis, you can do it. That is depends upon you. But if you are getting what are the X values, so X are coming in two ways based upon the particular the parameter of the age over here and as well as estimated salary. So 19 will represent the age and 19,000 that is represent the estimated salary. And Y will represent the person will purchase the product or not throughout the online advertisement. So after applying these things, if you want to find out the missing values, you can also find out that part. And if you don't want to do the same thing, you can't do it. Otherwise, next step that is the training and testing split. So again, we are using the same process over here, like sklearn dot model selection, and based upon that model selection over here, we have to import a train, test, and split. So after applying train, test, and split, we have to take on over here the x train, second parameter that is the x test. Then we have to take on a y train and the y test. So then we have to take on over here the y train and the y test over here, and we have to equal to with the train underscore test underscore split. And inside we have to take on a parameter of x. Also we have to take on of y parameter. Also we have to take on of test size, and here we have to take on test the size is equals to again similarly to the logistic regression 25 percentage as a test size, and then I want to take it random state is equals to 0. So now it's time to run this code, but here we are getting an error. I think again we are getting an error. Yes, that is the model selection are there. So that's why we have to take on a model selection over here. So till now we had completed the things. In the next part, we have to apply how to do the feature scaling with the standardization parameter and so on. We can learn about how to create a KNN model over here. So now after splitting the training set and testing set, particular with the KNN nearest neighbor, now it's time to apply the feature scaling based upon the KNN. So for that, we have to apply the next step that is based upon a KNN. So here, first of all, for applying KNN, we have to import the libraries like sklearn dot preprocessing, and based upon this preprocessing library, we have to import a standard scalar over here. So that's why we have to take a standard scalar. So after applying standard scalar, now in the next things, we have to create a one more parameter based upon the standard scalar, and that is the SC, is a short form of the standard scalar. So that's why we have to take an over the standard scalar of the bracket, and then we have to apply the enter over here. And now we have to transform our x train and also the x test with the transformation of the uh, standard scalar. So that's why we have to take an sc dot fit of transform of x train. Same thing we have to apply it for the x test as well as. So here we have to again take sc dot fit transform of x test. So now the feature scaling already applied over here. We have to take an sklearn. We have to take this one, and feature scaling is already applied over here. After applying a feature scaling, now it's time to apply it for a k nearest neighbor of model. Basically, during the theory, we are using the Euclidean distance. So at the same time, we have to don't forget that part, like how to apply the Euclidean distance as compared to the Manhattan distance. Okay, so same thing. What are the concept we had learned during the theory? Similarly, that type of concept we should provide during the practical as well as. So for doing the KNN algorithm, we have to import the k from the sklearn dot neighbors file. We have to import over here the KNN algorithms. So that's why based upon the KNN neighbors. So from the KNN sklearn KNN sklearn neighbors, we have to import KNN neighbor classifier. So KN, again we have to take capital neighbors classifier, we have to import over here. So please be careful with the spelling of this one, because somewhere we have to use capitals and somewhere we have to use small letters, and everything is depends upon the standard documentation of the scikit-learn particular algorithms. Okay, so that's why we have to follow that part. It's not my algorithm, like I have to take in KNN capital and then other parameter I have to use as a small. That is not on hand my own my. So because I have to follow the scikit-learn documentations. And now we have to try to create a model based upon the KNN. So you can also copy this code and you have to paste it over here, and based upon that you have to create this parameter like of things. So first of all, that is depends upon you how many k you want to select over here. So standardly during the theory we have to use k is equals to 5. So here also I have to use n neighbors is equals to 5, the things I can use over here. And after applying that one, now we have to select what type of metric or what type of technique you want to use, like you want to use Manhattan distance or you want to use the Euclidean distance. So according to that, here we have to provide the main cover schemes. Actually, if you can prefer the scikit-learn documentation more and more, so you will get an idea how you can make it some specified things. And as well as with the help of with the Euclidean distance, here we have to use p is equals to 2. If you can again use p is equals to 1, so at the same time it should work with the Manhattan distance. But here we want to work with the particularly Euclidean distance, because already in theory example we are using that one. That's why here I have to take on this one of p is equals to 2. So now we have to apply model dot fit, and we have to fit this model with the x train and also with the y train. So now it's time to run this code and we are getting an error. Let's check it out. I think we are getting an error based upon some spelling. I think yes, metric. Yes, spelling of metric was wrong. It's metric, not a metric. Still, we are getting an error. I think we have to check main Kowalski spelling was correct. P is equals to 2 is also correct. Let's check it out. What are the error we are getting over here? The metric min Kowalski is not valid over here. Let's check it out. Why it is not valid over here? We have to find out any type of the reason for that. It's a min Kowalski. I have to write down the mini Kowalski. Yes, now it's working. Over here, the min Kowalski, that is the function, but by mistake, I had taken mini Kowalski. Okay, so after applying these things, we can see over here, like k nearest neighbor that was make it over here. And next step that is based upon that is we have to predicting the test result as well as. So for that over here, we have to provide the y prediction over here. So y prediction is equals to, here we have to take on a model dot predict, and particularly with the predict we have to use x test over here. So we have to use x test, and after getting x test we have to run this code, and now we can call up y prediction over here. So that is the output of the y prediction. So after applying that thing, next thing that is the making a confusion matrix. So let's make a confusion matrix. So for that we have to write one code of for that, but before that we have to import one library to applying a confusion matrix, and that library is the from sklearn dot matrices. From sklearn dot matrices we have to import a confusion matrix. So that's why we have to take a confusion and then matrix, enter CM, it is a short form of the confusion matrix. So based upon the confusion matrix, here in the bracket we have to take a y test and y prediction. So now it's time to run this code and we are getting an CM. So if you can remember the things, whenever we should work with the logistic regression, at the same time we are getting the true positive is equals to 63, but here we are getting two true positive is equals to 64. So easily we are getting an idea as compared to the particular logistic regression in the KNN nearest neighbor algorithm, we are getting the good accuracy or the good result as compared to that one. So in the next things, we have to see about how to visualize the training set result and the testing set results. So for the visualization of the training set results, here I can use the same code, what the code I already use it for the logistic regression, because this code is taken lots of time to prepare that. That's why I have to copy the code from the logistic regression file. And here if you can see everything is looks similar to the logistic regression file, but just only we have to apply one change over here, that is based upon the title. Here we have to take an KNN regression test over here. Otherwise we are going with the same parameter, what the parameter we can already use for the training set of the logistic regression. So based upon that, here we are getting an output, but before that it will take some time to run this code because the code length is very large. That's why it will take in time, but it will not take more than like 1 minute. So now if you can see, this thing should complete it over here, and we are getting an output over here with the KNN. So whenever we should work with the logistic regression, at the same time we are getting one linear line over here, because particularly in a logistic regression should be worked based upon the sigmoid function. So that's why according to sigmoid function of S curve, we are getting that type of output. But here if you can see with the KNN neighbor algorithm, we are getting different type of the decision boundary. Basically this line is called as a decision boundary. And again here the same concept we can provide it, those concept we already provided based upon a particularly x-train and x-trace with the logistic regression. Now after getting the result based upon a training set, now it's time to take a result based upon the, after getting training set result, now we have to find out the result based upon a testing set. So to get the result based upon a testing set, here we have to take an y test and x test. Here we have to take an x test as well as, and rather than, again here we have to take an KNN testing set, KNN testing set. And now we have to run this code. Again, it will take 30 seconds. Okay, so here we are getting an output related to the testing set of a KNN. So the decision boundary still look like similar, but here if we can see in a green region, there are very few samples are there that is related to the red sample. So and also similarly to that, in a red region, we are just only having the three samples related to the green regions or the green sample, but all the samples are very nearer to the decision boundary. So that's why we are getting an idea as compared to logistic regression, the KNN algorithm are given the better result as compared to the accuracy as well as compared to the confusion matrix. After seeing the development of the KNN algorithm, in the next things we have to learn about the decision tree algorithm with the classification thing.